Hello students, welcome again. Last time we done vernier caliper experiment. This time we will do this experiment known as screw gauge. So this is the screw gauge and this is smaller one, mostly available in the labs. This is little bit larger, used in mechanical engineering, but I am using you so that I can make you understand very much. If you like our video, then please subscribe. I request you have to please subscribe and like the channel so that I encourage and give you more and more valuable videos of syllabus as well as experiments as well as competitions in future. Okay, my dear students, see, this instrument is known as screw gauge because it is based upon screw. Screw gauge based upon screw. And this instrument is more precise than vernier caliper, more precise than meter scale, more precise than vernier caliper. Meter scale precision value is 0.1 decimal. Vernier caliper, this one, its precision value is 2 decimal point, and this instrument's precision value is 3 decimal point. 3 decimal point. This is used in engineering to measure the diameter of cylinder, piston, cylindrical piston, which is to be fitted in the chamber of vehicles. Okay, so this instrument is so precise it can measure even thickness of a paper. So what to do? Move this from here. Don't move from here. Move from here and fit the paper sheet whose thickness to be measured and rotate from here. And when there is a clink sound, stop like this. Listen, stop then. Okay, and then you can measure reading from here. Now I will tell you how to measure reading. So this instrument, in the case of this instrument, first we have to calculate pitch. What is basically pitch? Pitch is the linear distance traveled by this cylinder in one full rotation. See, to understand you, here it is written 40 and I come here again 40. So how many divisions are visible below? On linear scale, 1 division. So its pitch is 1 division value of linear scale, and that is in 1 millimeter. 1 millimeter. 1 division on linear scale. This is the linear scale, my dear students. This is the linear scale. This one. This is linear scale, and 1 division is equal to, on this linear scale, 1 millimeter. 1 division equal to 1 millimeter. So how many millimeters in one rotation covered? That is known as pitch. So normally we will rotate it by 4 times. Okay, see, it is 40 here, again 40, again 40, again 40, again 40. So my dear students, how many divisions are visible below? You can see on the camera 4 division. So pitch is distance moved by screw on main scale. So this distance moved is 4 millimeter. And how many rotations? 4 rotations. So pitch is 1 millimeter, 0.1 centimeter. This is the pitch value of this linear scale. Now list count. Least count is the minimum measurement taken by an instrument, that is known as least count. So least count formula is pitch. So its pitch is 0.1 centimeter divided by number of divisions on circular scale. My dear students, see this instrument in my hand, the big one. There are 45 and 5 more 50 divisions. So 50 divisions on this instrument, and on this instrument mostly available in classes there are around 100 divisions. Very little, say not visible in camera. There are 100 divisions. So maybe on the small one, on bigger one in my hand 50, and on smaller one in my hand 100. So its least count is 0.001 centimeter, and in this case it is 0.002 centimeter. So if number of divisions on circular scale are 50, then it is 0.002 centimeter. Check on your device how many divisions are there. So if 100, then 0.001 centimeter. Now I will let me tell you how to take reading. Before going for reading, first of all, check positive error or negative zero error. Positive error is subtracted and negative error is added at last in the final value. Okay, very simple. Very simple. If I close the instrument without adding here anything, just plain closing, if the zero go above, then if the zero go above, then it is a negative error. So in this case it is negative error. Zero go above, zero is here. This is the reference line, my dear students. This is the reference line. This is the reference line. This one. This is a reference line. Now close till the clink sound come. Close it. Okay. Now see, 0 go above. So it is negative error. If 0 come below this reference line, if 0 come below, then it is positive error. Once remember one side, if 0 go below the reference line, if 0 of circular go below the reference line, then it is negative error, positive error, then it is positive error. And if 0 go above, if 0 go below, positive error, 0 go above, negative error. Okay, if 0 go above, it is negative error. If 0 go below the reference line, this is the reference line, then it is positive error. So in my instrument, on this big one, on closing like this clink sound come from there. So I checked out how many divisions 0 passes. 0 passes, so it is a negative error. Here it is 36. So 36, my dear students. So how many divisions above 0 is here? 5, 10, 15, 16 divisions above. So in this my instrument, bigger one, 0 error is, there is a negative 0 error, and it is equal to 16 into least count. So it is 16 into 0.002. So it is 0.032 centimeter. This is the least count in this case. And in the smaller one, I am using two 150 circular scale division and one is of 100. On the smaller one, yes, here again there is negative error because 0 crosses the reference line and there are 10 divisions above the reference line. So in the smaller one, list count is 0 error is 10 into list count. It is 10 into 0.001. 10 into 0.001. So it is, you can say, 0.010 centimeter. 0.01 centimeter. Okay, this is the error. Okay, now reading, very simple formula to take reading. Reading formula is, what is the reading formula? My dear students, reading formula is very simple. Linear scale reading plus circular scale reading into list count. This is the reading formula, very simple. So in this case, if we have to measure, first of all, let me check you by this bigger one instrument. Insert the thickness. This is so precise instrument. It can measure thickness of this paper, only very small thickness. So put this paper here and rotate this cap till the sound come. Oh, okay, very low sound. You are not able to listen. Okay, so here it is. Listen. There is no division visible on circular scale. So circular scale division is 0. Circular scale division is 0. Linear scale division, my dear students, 42 is visible. See, very simple, this bigger instrument. This is the reference line, my dear students. This is the reference line. This one, this one, this one, this one. This line I will show you. This is the reference line. This one. This is, see, this is a reference line. This is a reference line. So insert your paper here like this. Insert the paper here whose thickness to be measured and rotate the cap till the sound come out. Okay, now see how many divisions are in front of reference line. In front of reference line there are 40 circular scale divisions. See, 40 is in front of reference line. So circular scale division is 40. So according to formula, reading is 0 plus 40 into list count, and list count of bigger instrument is 0.032. 0.032 centimeter. So 40 into 0.032 and it will come out 40 into 30.032. Okay, 40 into 32, if I will do, it will come out 1.28 millimeter. Okay, you can say this value is 0.128. 0.128 centimeter, 0.128 centimeter, and here it is a 0 error of 0.032. it is negative, so we have to add it. Plus add 0.032, 0.032. So 128 and added 32, 0.032. So thickness is 0.160 centimeter. This is the thickness of this paper sheet. Repeat the experiment 3 times. Second reading. Okay, second reading. Again remove it from here and again insert it here like this. Again insert. Okay, rotate the cap and rotate the cap very gently, and again see in front of reference line there is 41, 42. Linear scale not visible, 0, 42, 0 plus 42 into 0.032. So my dear students, there is a big mistake here which I had done. You can also do this, so please be careful. Here it is list count. List count of this instrument is, list count of the bigger instrument is, we have to multiply by list count, and list count here is 0.02, sorry, 0.02. So this value is 40 into 0.02, 0.002 centimeter, and second time it is 0 plus 42 into 0.002 centimeter. This is second time reading, and it will come out, and at last what is the answer? 40 into 0.002, and do this 2 upon 4 into 40, 8 upon 100, 0.08, 0.80 centimeter, and corrected value is 0.080 centimeter, and corrected value is negative error I did, so it is plus 0.032 centimeter. So at last we will get 0.112 centimeter thickness, and in second reading this is 0.084 centimeter and 0.084 centimeter plus 0.032. Negative error is added, so it is 6.116 centimeter. Similarly, third reading, okay, make that correction. Okay, you have to use list count. List count is 0.002 here. By mistake at that time in first reading I had taken this one 0.032. This is zero error. This is the zero error. You have to add the zero error at last. And now take third reading. Again remove the sheet and put the sheet here, and move this cap. And my dear students, now this time it is 41. See, you can see very clearly 41. So third reading is 41. So 0, linear scale value is 0 plus 41 into 0.002. So this time it is 0.082 centimeter, 0.082 0.82 plus 0 negative error is added 0.032. So this time it is 2.114 centimeters. So 3 readings are taken. So what is the final value? What is the average value? Mean value? Mean value is 0.112 centimeter plus 0.116 centimeter plus 0.114 centimeter divided by 3. This is our last answer. So my dear students, if you use this one, smaller one, then use list count this 0.010 here, 0.010. Use this one then. If you are using this one, smaller one instrument, then use this error and use this list count 0.001 list count, and this is negative error added at last, and this is the list count. Use here then 0.001. If you use this instrument, use 0.001. So again I am repeating again, once again, pitch, that is distance move on screw by the screw on main scale over number of rotations. So my dear students, basically how much distance is visible on this linear scale in one rotation, that is pitch. So rotate 4 times and see how many divisions are visible below. So I rotate it 4 times and 4 divisions are visible. So here it is written, and 1 division is equal to 1 mm. Here this is written on the instrument, somewhere else written on the instrument, 1 division equal to how much mm. This is written here, 1 division equal to how much mm. So it is written here. So like this is your screw gauge. Okay, if you like the video, then please subscribe our video, like our video, encourage me so that I can give you more and more experiments. Thank you.